Hello there all, welcome back. In the previous videos, we have already gone ahead creating this particular table and understanding a little bit about procedural modeling. In this video, I'll go ahead and start cleaning up this particular model before converting it into a digital asset in the next video. One of the first things I actually want to edit about this particular table is if I turn on the construction plane, you can see it extends way below the construction plane itself. So I want this table to actually sit on top of the grid. So to do this, once all the objects are merged and the final table is created here, I'm going to add in a particular transform node to move it above. So to do this, I'll right click on the end of my merge node and type in transform. And here I have my transform node. I'll select that, drop that in. And now, selecting my transform node, if I want my transform handles visible in the viewport, I can just come here, press enter, and now move the table to sit on top of the grid. The problem with just moving it randomly like this is if I go ahead and here, my height taper, increase the height of the table, you can see it again goes below. I don't really want that to happen. So instead what I can do is, because my height of the table is linked to the height coming in from this height taper node, and if I change the option here, you can see it's my z-axis translate which is moving. I can just go ahead, copy the value from here, so copy the parameter from the z-axis of my extrude and come back to my transform here until I want the same translate applied here in y-axis. So I'll right click here and use paste relative reference, and when I do, you can see the actual table goes down in the negative direction. The reason being, if I click on translate, you can see it's coming in as a negative value. I actually want it to be a positive value. So again, coming back to my expression, you can see it's nothing but a simple channel expression. It's going back to its parent node, which is the geometry. It's finding the height taper node, and in there it's using the local translate z-axis. I'll just put in a negative sign in front of the channel node, and now the table is sitting exactly on top of my grid itself. And this time, if I come back to my height taper and change the height, you can see the table actually increases its height on top of my construction plane rather than below it. Now that we have finished setting the table on top of the construction plane, let's add in a few more edits. So here, the table top is actually extending way beyond the edge of the table legs. I actually want them to be completely flushed. So to get this result, first thing I have to edit is if I go to the polygon extrude and start changing the value, you can see there is a certain value which if I reach, both the tabletop and the legs look flushed. So I want to make sure this is also procedural. So if I come back to my leg taper and disable this just for an instant and go over to my top view and turn on wireframe, you can see that they're almost flush but not exact. There are a couple of things I want to understand here first. You can see if I disable my polygon extrude here that my table leg is actually sitting with its center on exactly the corner of my table. So that means it's exactly at the half distance. So to cover the entire distance, I just need to go half the distance as the size of my table leg. So if I go to my table leg, you can see I have a certain size here. I can just copy this parameter. I can come over to my polygon extrude, which is giving me the extrude value. Here I can paste in the relative reference, and then I can just divide that by 2, and you can see immediately the line looks flushed. Also, I can just come back to the leg, start changing the size, and you can see the legs continuously change. So that is done, but there is also a certain issue right now. Because I'm clicking on the size value, middle clicking and using the value ladder to change the size, if I go ahead and start changing the size on only one axis, you can see that it does not work anymore. The reason being, I've only connected one single parameter, that is the size X. So the size Y has absolutely nothing to do with the actual extrude. So what I'm going to do is drive the size Y also using size X, because as we can see, both of them have the same value. So I'm going to just copy the parameter and here paste relative reference, so you can see size X is the same thing driving size Y. Now all I need to do is edit size X and it edits the edge of the table. Coming back into my perspective, if I turn on my height, you can see by changing the width of my legs, the actual table extends so that it's always in flush with my legs. So now that I've finished with a few of the edits on the table, I want to go ahead and see what are the different properties I want to be able to change for this table. So the main properties I could think of are the length of the table, the width of the table, and the actual height of the table itself. So the length and width of the table are actually coming in from the top base, where the length and width are nothing but the size in X and Y for the top base. Then the actual height is coming in from the height taper node, the extrude node, which is going here. So this is the height of my table. Now after this, the other thing we might want to edit is the actual thickness of the legs. So coming to the leg itself, we can change the thickness of the legs. So let's say 4 parameters that we want to edit. But if we have this file, it'll be harder to tell people where to go to edit what. It would be much easier if we have a single place, a single control object which lets us edit all of these parameters. So let's create a control object to control all of these different parameters of the leg. Now to create the actual control object, I want it to be a particular node which does not have a lot of parameters. For this, I can make use of the null node. So the null node basically has few options related to the input, but because I'm not going to connect it to anything in the node network, I can just leave it as it is. Now let me go ahead, just give it a color so that it's different from all the other nodes in the tree. What I want this null node to have are controls for controlling the length, width, and all the other elements. First, let me go ahead, change the name to CTRL for a control object. The main reason for having a shorter name is so that it's easier to read in expressions, as we'll see in a few minutes. Now I want to add in some sliders which let me control all the properties. So to add in the sliders, I need to click on the gear icon, go to Edit Parameter Interface. Here it brings out the huge dialog box which lets me add in several kinds of parameters. But before that, let me hide the initial ones which are already there on the node. Select the node, turn on invisible. Select the next node, turn on invisible, hit apply, and the interface elements are gone. Now I want to create floating point numbers which actually control the length, width, and other elements. I'll talk about all the other parameters which can be created in other videos, but for now let's just go ahead and use the floating point numbers. So selecting the floating point numbers, I'll just press this right arrow here. So 4 times, because I want to control 4 different parameters, I need to give them proper names. Now because our table, when it's in 3D, doesn't actually have anything which distinguishes it from length to width, I can't actually give the same name, at least as a computer name, because it gets confusing because we don't know which axis is going to go which way. So let me give a particular computer name and then something else which is easier to understand here as a label. Before that, hitting apply, you can see all of these elements are created here. For the first element, which I'm going to call the length, I'm going to give a computer name L_x because I want that to be the x-axis. I'm going to call it length. If I hit apply, you can see the label here for this parameter has changed, and by hovering over it for a while, you can see the parameter is called L_x. I'll just go ahead and do the same thing to the rest of them. So L_z, I'll call this the width. L_y, I'll call that the height. And finally, I'll just call it thick for the table leg thickness. Hitting apply, all the properties are created. I'll just accept them. Now, if I directly go ahead and try to control the object using these properties, you can see nothing actually works. Reason being, it's not actually connected to any of the properties we have already seen. Now, because we want to go connect them, we want this always visible. So let me go ahead, pin this particular node so that when I select something else, it does not get refreshed. Now, to get another properties bin, when I'm in the network view, I can press the P key, which opens up another properties bin where I can go select any object and those properties are visible. So let me go ahead and add in all the properties which I've created. So the length property, I'll copy the parameter, I'll select the top base, and here it goes into the size X and size Z. So here I'll just go paste in the relative reference from the length, copy parameter from the width, and paste that in here. Now if I go try to change the length and the width, you can see the table actually changes. Apart from that, I can go change the height by copying the parameter of height, selecting the node, putting that in z-axis, but the height goes in reverse because it has to be in negative because it's going against the normal. I'll go put a negative sign in front of it, hit enter, and now the table's correct again. Again, to create the leg thickness, I'll copy the parameter from here, go to the leg, and here only in size X I need to paste the relative reference. Now you can see that anytime I paste the relative reference, I'm actually getting to see the expression. And because I've given the simple name CTRL to my control object, the expression is much smaller. If you give a long name for your control object, your expression will be unnecessarily long and it'll be harder to read. So that's the reason I gave it a shorter name. Now I've gone ahead and connected all of these parameters. I can now go change the length, the width, the height, and the thickness of my table legs easily from right here. Now let me go show you the benefit of having done it this way. If I go back to my scene view, select my object node and duplicate this by Ctrl+C, Ctrl+V, you can see I have another table. And now taking my manipulator handle, I'll move this table to the side, dive into this table, and here I have another control object, and selecting this, I can now change the parameters and get a completely different looking table very easily. So once I've created a particular table, I can easily go ahead and keep duplicating it as many number of times as I want. So that's pretty much creating a model in Houdini and controlling it, but it's not yet a digital asset. What a digital asset means is that just like how you create a box, a sphere, or a tube and control the parameters of those objects, you can create a table digital asset which stays right up here in the shelf. Click on it and you can change the length, width, and height and create a new table. So that is what we are going to look at in the next video and understand how to create digital assets, and also a couple of things about how to troubleshoot certain issues which come about when we create these objects. So I really hope you found this video useful. Of course, if you have any doubts, critics, comments, please put them under the video and I'll definitely get back to you. I'll see you in the next one.